Part 2, chemical kinetics. We're talking about the average rate of reaction. And this is a change in the concentration. The change in the concentration of the reactant or product over a time interval. Now, if I want to write the average rate of reaction of this equation at the board, for A, it is minus change in A all over change in T. Now, whenever you see this symbol, it means change. Now, and in mathematics, if I write something like this, change in x is the same thing as x2 minus x1. So in average rate of reaction, we use change in the concentration of A all over change in concentration of time. Now remember, we are including the minus because of what? The reactant is decreasing while the product is increasing. And so this is what? Changing, this will be equal to minus change in the final concentration all over change in the initial concentration, or let me write it this way. This is equal to so this is will be equal to minus the final concentration of A all over the initial concentration of A, or we have minus here. And if I ask you to write that of B, the rate average is the change in concentration of B all over change in T. And that will give you BF, concentration of B initial, all over TF T0. So that is how to write the average rate of reaction under chemical kinetics. Now, what will come subsequent will be examples. We have an example at the board, and they ask us to calculate the average rate of reaction between 400 and 600 seconds. So this is the time, because this is the concentration. So remember, the average is the change in the final minus change in the initial all over the time in the final and minus the time in the initial. Looking at this question, our final is 600 and the initial is 200, and the initial is 400 from the question. So all we need to do right now is this concentration. That of the 400 is 600 is 1.15 minus the number of the 400 is 1.28 all over the time is 600 minus 400. So the rate average is equal to, if you minus this and you punch it in your calculator, what you should get is 6.5 times 10 to the power of minus 4. Of course, remember that the SI unit is mole, or you can still call it molarity per second, or you can still say this is mole per meter per second. Any of this is with the SI unit of the rate of reaction. We said it in the part 1 of the video. Please endeavor to check it if you're having confusion with it. Example number 2, we have a table, we have an equation of the reaction. On the table above, calculate the average rate of disappearance of this, of NO in the first 20 seconds. Now, this is 0, 10, 20. So the first 20 seconds, they're talking about here. So this is where the first 20 seconds is. Now, of course, the first 20 seconds, that means that this is the final and this is the what? Initial. It starts from 0 and they say end in the first 20 seconds. So, of course, we're writing the average rate of NO. So, here, look at what I'm going to do. Remember from the equation that our NO is at the product side. And so that means that it is disappearing, it is decreasing. So the average, of course, should be negative. So from here, we are going to write the equation. Now, from your answer, you should know that your answer must contain negative. Writing the equation, you have NO final at the initial, and the T final minus T initial. Now the NO here at 20 seconds is 0.586 minus at 0 is 0.75. 1 over 20 minus 0. Now, punching this in your calculator will give you, of course, please here, this is 0 here, polarity. This will give you minus 8.2 times 10 raised to the power of minus 3 molarity per second. You can see from our answer already you are having minus. Why? Because from the equation, this NO is at the product side and it is disappearing. So that is all